Now we're going to do some quick examples of using lists inside functions. And most of it's pretty intuitive and what you would expect, but we're just going to walk through some different scenarios. So let's look at this one. Here we have a list passed in as a parameter. So the countOdds function takes in the list A. So we just pass it in the list A. And then it essentially can use it like it would use any other list. And so it says that there's 4 odds inside of this list. It also turns out that we can also destructively modify lists which are passed in as arguments. So if we look at this code, we pass in the list A to the function fill. When I call the function fill, let's see what it's doing. Essentially, it's taking in this value, and for every element in A, it's saying A at that position is equal to this value. So if I called fill on 42 and the list A, it should return that the list A has all 42s. Now notice that this function doesn't return. And remember when we talked about destructive versus non-destructive functions, we said that if a function is destructive, it doesn't have to return anything, and so in most cases it returns none. This is the situation here. The function fill does not return anything, it in fact returns none. However, when I call the function fill A, we can see that before I called it, the list was 1, 2, 3, 4, 5. After I called it, it was just 42, 42, 42, 42. Notice that we didn't do anything like A equals fill of A. And if we did this, let's actually think what happens. I call fill of A, it makes A 42, 42, 42. Then I say the return value of fill is equal to A. The return value of this function is just none. So A should be none. So if I run this, then it says A equals none. So in fact, we just pass in A, let the function do its thing, it destructively modifies it, and then we don't have to set it equal to anything. We just know that after line 7, the function has done its job, and so the list A is now different. So this is the fact that we can modify functions destructively when it gets passed in as arguments. Now, next we'll look at doing things destructively versus non-destructively. It turns out that any single function you could ever write destructively can always be done non-destructively. So, in this example, we remove all the elements in A destructively. We go through each value and we do a.remove of value. Or sorry, we don't remove all the elements, we remove all the elements of the number value. So if, let's say, we call the list A on value 2, it would remove all the 2's from A. Now, we do this destructively by just doing the .remove method, which we all know from previously is destructive. However, we can do any function that we can do destructively, we can do it non-destructively by this simple method. Instead of just writing this code, first, just set A equal to a copy of itself. So now we're no longer looking at the list which was passed in. We're looking at a local copy. Then just do the same code. And the thing is that if we just ran the code and we didn't return anything, then this function would return none. And we wouldn't have modified the original input, so it would be as if nothing happened. So, as we know with non-destructive functions, you have to actually return what you did. So here we return the list A, which is a new list A, which we modify. We do not modify the old one. So we look at what's happening. We make the list A is equal to 1, 2, 3, 4, 3, 2, 1. We destructively remove all the 2's. And when we destructively remove the 2's, the list A now has no 2's. However, if I non-destructively remove all the 3's, we can say that the list A still has all the 3's because we did not destructively remove them, but the list B, which is what the non-destructive function returned, is the list A without 3's. So in this way, we can see that we can modify lists both non-destructively and destructively. Finally, this is just a quick example to show you that you can return lists from functions. So we write this function, numbers with 3's, and essentially what it does is that it finds all the numbers between this range that have the number 3 in it. So like if it was from 20 to 30, then it would basically say, okay, 23 has a 3 in it. We just build up this result list, and then we return the list. So this should come as no surprise to you that we can write functions that return lists. We make the lists inside the function, and then we return it. So these were some quick use cases of when you use lists inside your functions.